We take dozens of photos every single day, completely taking for granted the physics happening the exact moment we tap the screen. We think of it as a simple mechanical action, a physical shutter opening and snapping closed to freeze a moment in time. But inside your smartphone, there is no mechanical shutter. Once light travels through the external glass lens, it hits a completely flat, microscopic piece of silicon known as a CMOS image sensor. Zooming in on this silicon field reveals a precisely engineered grid made of up to 12 million individual microscopic buckets. And instead of catching raindrops, these hollow receptacles are designed to catch photons, the tiny physical particles that make up light. When you hit the capture button, you are opening the lids on all 12 million of these light traps at the exact same instant, orchestrating a massive simultaneous measurement of physical energy. This diagram illustrates exactly how that measurement works. As photons pour in, the sensor measures the precise volume inside each bucket. If a bucket fills completely to the brim, the sensor registers a bright spot for that pixel. If it catches nothing and remains completely empty, that spot is recorded as pitch black. But there is a massive engineering hurdle hidden in this design. These microscopic traps are incredibly precise at measuring the physical volume of light, but they are entirely colorblind. They record exactly how much light fell in, with absolutely zero awareness of what color that light was. The pure data coming off your camera sensor is entirely grayscale. To get from a grid of black, white, and gray measurements to the exact vivid blue of the sky requires a highly specific physical hack. Engineers created the Bayer filter, a microscopic stained glass roof installed directly over every bucket. These lock into a repeating pattern of exactly one red, two green, and one blue square. Now, a bucket under a red pane collects only red photons, blocking everything else. Solving the color problem creates an immediate side effect. Because every single bucket is now registering only 1/3 of the visible light spectrum, the raw data your camera captures is a fragmented, heavily pixelated checkerboard mosaic of red, green, and blue squares. If you were to look at this raw file directly, it would be a completely unusable image. The physical hardware has hit its absolute limit, requiring a secondary, non-physical intervention to create a recognizable picture. That intervention happens inside a dedicated piece of hardware called the Image Signal Processor, or ISP. This is the algorithmic brain tasked with translating that fragmented mosaic. Decoding millions of isolated color values requires immense computational strength. Advanced smartphone architecture, like the A19 Pro chip, dedicates massive portions of its physical footprint specifically to feeding and powering this one processor. The instant you hear that artificial shutter click on your phone, the physical capture is over. All of that raw, incomplete bucket data is instantly rushed off the sensor and directly into the ISP. To make sense of the mess, the ISP isolates a single pixel within the massive grid. It pinpoints one specific colored square and begins its calculation. This is the exact moment photography shifts from the physical capture of real-world light into an exercise in pure mathematical deduction. This diagram shows the logic in action. The processor looks at a single red square, then scans the data from the green and blue buckets immediately surrounding it. By analyzing the intensity of those neighbors, it uses complex mathematics to logically deduce the exact missing blue and green values for that central red spot. Once it cross-references those neighbors, the algorithm outputs its final answer. It assigns a specific combination of red, green, and blue numbers to that single point, each ranging on a strict numerical scale from 0 to 255. As it calculates these values, it simultaneously smooths out the rough edges, correcting the heavy pixelation and stripping away visual noise across the entire image. The vibrant pixels you actually see on your screen are highly calculated, algorithmic guesses perfectly executed by your phone's silicon. With the exact shade calculated, that specific color is permanently locked into your phone's memory, taking up exactly 24 bits of ones and zeros for every individual pixel. The scale of this operation is staggering. The ISP runs these complex neighbor calculations, making billions of microscopic adjustments across millions of pixels, all in roughly 1,000th of a second. Pointing a phone and tapping a screen feels like a completely mundane action. But behind that glass is an unbelievable, rapid-fire dance of physical science and intense mathematics. Your phone relies on an architecture of microscopic light traps and algorithmic logic to freeze reality and time. If you want us to dive even deeper and look at how the physical glass lenses actually bend this light before it ever touches the silicon, drop the keyword lens in the comments below. Keep exploring, and I'll see you in the next video.